Okay, here we are, starting to lay out the parts for this H-bridge driver for those robotic arms. Now each arm has a total of 5 DC motors, so we'll use 3 chips, 3 quad half H-driver chips, and we'll have 1 spare left over. Now I'm going to lay this out on some perforated board, kind of a universal breadboard thing. We could create a custom printed circuit board, but for the first one, just off the shelf here, this should work fine, and I'll show you how to do this kind of wiring. First step is simply kind of lay out where things go and where you want them. We have 3 chips. I have a set of pins here, and what I'll do is I'll make each row going this way be the enable forward and reverse for 1 half, enable forward, reverse for the next, and so on down the row, so I cover all 6 motors. There are 4 potentiometers on the robot arm, so I will bring out the signal from each potentiometer, 1, 2, 3, 4 on this set of set of header pins. Now they'll actually be connected to the robot arm through a multi-conductor cable. And I'll also have a multi-conductor cable coming out to make it easy to hook up to our National Instruments devices. But having these headers available makes it easy to hook up scopes or voltmeters and things like that. These pins I'm planning on for the 5-volt reference and ground. Depending upon what kind of device I'm connecting this to, I may want to use the 5-volt regulated power here as the analog reference and ground, or I may want to use 5 volts from, say, an Arduino as the reference and ground for our sensors. So I'm going to connect the pins here through these pins to power and ground from the regulated power supply here, and the other 2 pins will be connected to power and ground that goes to the potentiometers, and by shorting these pairs together I can use the power and ground from this board, or by leaving them separate I can use the power and ground from another source. I have a breakout here for 12 volts. This is the 5-volt regulator to give me the 5-volt supply for each of these chips. There will also be the unregulated supply that will go to the motor control side. A couple filter capacitors to keep the voltage clean, and these will be the 6 outputs going to each motor, forward and reverse. Now, these will go directly to the 25-pin miniature sub-D connector on the connect directly to the robot, and you could argue that I don't need these, but the nice thing about having these is that I can hook up easily to a scope and look at the voltages and see how well we're clamping the flyback voltages, the back EMF, and look for noise. And then I have some resistors that I'll put in between the input pins and my signals here to isolate those. There'd be a LED indicator that tells me when the power's on. And another thing I'm going to do about this, if I wire it up like this and I put it in the box, and I put the top on the box, now these breakout or header pins are going to be buried pretty deep. So what I'm going to do is when I actually solder this, I'll take them and put them on the board from the back this way, which is hard to see. There you go. This way. So then on the bottom of this box, which fits this board, I'll be able to make the cutouts in the box and access those pretty easily. But be careful not to tip because everything falls out. So I'm going to take the headers out for the moment and start by soldering in these chip sockets. Each chip socket will hold one of the one of these quadruple H drivers, and we'll solder in the power supplies and things like that, and go from there. Okay, to start with, I've got the 3 chip sockets in place. They're probably difficult to see on the screen. I'm going to just basically apply a little bit of heat, a little bit of solder, a little bit of heat, a little bit of solder, and solder each of those pins to the breadboard. I don't have to, they don't fall out. Go over here and catch this one so it doesn't fall out while I bump things around. Key to soldering is not too much solder. Enough, but not too much. Enough heat, but not too much heat. There's nothing particularly difficult about soldering. A little practice. And I'll go solder up the rest of those, but I'm sure you don't really want to watch. At this point, I have the sockets mounted, the components for the 5-volt regulated power supply are mounted. The headers are mounted on the back, as I said, so that when we put this in the case, I can put it in the case this way, make the cutouts in this side of the case, and those are all accessible. Next step is to start stringing wire, actually. Now I've run a couple pieces of copper wire here down the middle to make a ground bus. If you look at the diagram for the chip on the data sheet, you see that these middle pins on both sides, pins 4, 5, 13, and 12, are heatsink and ground. So I need to get connected to all 4 of those, and I'm using 2 lengths of wire so it at least has a little bit of mass to carry away some of the heat. Ideally it would be connected to a large copper ground plane to carry away the heat, but we don't have that with this kind of perf board, so I'll just solder it to a couple wires and we'll see if that's successful. It starts at this header pin, connects to the ground pin on that voltage regulator, the ground of those filter capacitors through those grounds, and then I can tie in other grounds along the way where I need them.